Welcome. Welcome to All This Math. This is Professor Parker, and today we're going to talk about logarithms. Logarithms. Logarithms are useful. Most of the time, when you're presented with math problems, you're given an exponent, right? Let me write down an example. Let's say you're given 3 to the second power, and your job is to evaluate this or simplify this. 3 to the second power means 3 times 3, because this exponent 2 identifies how many 3's are going to be multiplied. How many 3's are going to be multiplied? So if that exponent was 1, that just means that there's just one 3. So 3 to the first power is just 3. If that exponent was a 4, that means you would do 3 times 3 times 3 times 3. 4 3's will be multiplied. And the exponent tells you how many of that base, or that number, or that term, will be multiplied. How many? All right? Now, usually you're given the exponent, and that's called exponential form. But what logarithms do is, let's say you know the outcome that you want, but you need to know what the exponent would be. That's where logarithms come into play. Because a logarithm, essentially, with the abbreviation log, which is short for logarithm, written up here, the logarithm tells us, okay, I need you to tell me what exponent would this 2 have in order to give me an 8. So what exponent would this base 2 have in order to equal 8? So let me show you something let me show you like a translation of this in exponential form, right? Check this out. So like I said, this is logarithm form. Now I want to write this in exponential form. So this 2 is my base, right? What this is equal to is going to be my exponent, right? Or this x is going to be my exponent. Now, this could be any variable. It doesn't matter what the variable is. It just so happens that it's an x, and x sounds like exponent, but there's really no correlation. That's pure coincidence. This number with this exponent should be equal to this number. So I'm going to rewrite that like this. 2 to the x, which is still a base, because here is a base and here is a base, is equal to this number, which some textbooks call that the argument. This number 8 and this number 625 are called arguments. So now this is logarithm form. This is exponential form. Now in exponential form, we basically ask ourselves, okay, 2 to what power equals 8? How many 2's need to be multiplied to give me 8? 2 times 1 is just 2. That's not 8. 2 times 2 is 4. That's not 8. But what about 2 times 2 times 2? That's 8, right? So that's 3. That's 3 2's. So that would mean that x is going to be equal to 3. Right? Excuse the noise. So, x equals 3, because 2 to the third power is equal to 8. Because 2 times 2 times 2 is equal to 8. So that means that over here, this will be equal to 3. The logarithm base 2 of 8 is 3. Now, let's go to number 2. It's another logarithm. Logarithm base 5 of 625 is equal to x. So 5 has to be multiplied how many times to equal 625? Let me rewrite this logarithm in exponential form. Once again, my base is 5. My exponent is this right here. This is the argument. It's equal to the argument, 625. 25. So 5 to the x power is equal to 625. 5 to the x power is equal to 625. So how many 5s need to be multiplied together to equal 625? 5 times 1, let me just give you the list. 5 to the first power is 5. That don't work. 5 to the second power is 25. 5 to the third power is 125. 5 to the fourth power would just be 125 times another 5, which is going to be 625. So that means that x is equal to 4. So we got x is equal to 4. So that equals 4. All right. So that was just a little introduction of some fundamentals on logarithms. Nothing too heavy, nothing too major. At another time, we're gonna do some logarithmic equations where it gets, kind of really involved and kind of fun, right? But this was just an introduction to logarithms, what they are, and how they relate to the same expression or the same equation in exponential form, though. That's all this was. So, thank you for tuning in, and please continue to send your math questions to the All This Math DM, and your problem might make it to this board.